Hello viewers, in today's class we are going to take up the topic angle between a plane and a line, right? So here we have a plane and the equation of the vector equation of the plane is vector r dot vector n is equal to d, right? And the vector equation of this line is vector r is equal to vector a plus lambda times vector b. Now here we have to find the angle between this plane and the line, right? So the angle between a line and a plane is the complement of the angle between the line and the normal to the plane. So let us see what does it mean. Now here this is the normal vector. The vector which is perpendicular to the plane is vector n, and this is the line. Now the angle between this normal vector and the line is taken as theta, and obviously this angle will be 90 minus theta. Now here we have supposed that 90 minus theta is equal to some angle phi, right? So phi is actually the angle between the line and the plane. So here theta is the angle between the normal vector and the line and from this vector equation we know that this line is parallel to the vector b, right? This line is parallel to this vector b, so we can write theta is the angle between the normal vector and the vector b, because this line is parallel to the vector b. Now if we take the scalar product of vector n and vector b, we get the mod of vector n, that is the magnitude of vector b multiplied magnitude of vector n, the magnitude of vector b, and here we have the cosine of angle theta, right? Now we know that this theta is equal to 90 minus phi, right? From this equation we see that theta is equal to 90 minus phi, so therefore cos theta is equal to cos of 90 minus phi, and this is equal to sine phi. So here we can substitute the value of cos theta as sine phi. So we have here this expression, right? So sine phi can be written as vector n dot vector n divided by the product of the magnitude of vector n and vector b. So this is the required expression which is used for finding out the angle between line and plane. Here the angle phi is an acute angle, so we take the absolute value of this expression, right? So let us take some examples to illustrate this discussion. Let us take this problem. Find the angle between this line and the plane. So here the equation of the line is given in the form x minus x1 divided by a, y minus y1 by b, z minus z1 by c. Now see here if the equation is not in the standard form, our aim is to first convert the equation into this form, right? So here there is no problem because the equation is given in this standard form. So here the direction ratios of the line, the direction ratios of the line are given as A, B, C. So here we have 2, 3 and 6, and the Cartesian equation of the plane is given in the standard form, in the general form, ax plus by plus cz plus t is equal to 0, and from here we see that the direction ratios of the normal to the plane are A, B and C, capital A, capital B and capital C. So here the direction ratios of the normal to the plane are 10, 2 and minus 11, right? So the vector n is given by these components and vector b is given by this component, right? Or in other words, we can also write as vector n can be written as 10i cap plus 2j cap minus 11k cap, and vector b can be written as 2i cap plus 3j cap plus 6k cap. Now sine phi is equal to the dot product of vector n and vector b. So this is 10 2s are 20 and plus 2 3s are 6 and minus 11 times 6 is minus 66, right? And divided by the magnitude of vector n, that is the magnitude of vector n is 10 square plus 2 square plus minus 11 square, and if we calculate this expression we get square root of 225, this is, and this is equal to 15, right? Okay, now the magnitude of vector b can be calculated as this is square root of 2 square plus 3 square plus 6 square, and this is equal to square root of 49, and this is 7, right? So here we can write for the magnitude of vector n we can write 15, and here we can write 7. Okay, so sine phi can be written as this is 20 plus 6 26 minus 66, and that is equal to minus 40 divided by 15 into 7, right? So if we simplify it we get 8 by 21, right? So therefore phi can be written as sine inverse 8 divided by 21. So this is the required angle between this line and this plane. Now viewers, let us consider two situations. The first one is if a line is parallel to a plane, then what will happen? See, if this line is parallel to the plane, then we see that this normal vector will be perpendicular to the line, right? This is the line, and the line is parallel to the vector b. This line is parallel to this vector b. So if a line is parallel to a plane, then we conclude that the normal to the plane is perpendicular to the line, or the vector B, which is parallel to the line, is perpendicular to the normal vector to the plane, right? So it means line parallel to plane implies that this vector n is perpendicular to vector B, right? And this implies that the dot product n dot B should be equal to 0, right? So the dot product of these two vectors is equal to 0 whenever the line is parallel to the plane. Now consider the second situation. If the line is perpendicular to the plane, if this line is perpendicular to this plane, then it means that the line will be in the direction of the normal, or this is the normal vector, and if this line is perpendicular to this plane, it means this line will be parallel to this normal vector, and the line is parallel to this vector B, so this normal vector is also parallel to the vector B, right? So whenever a line is perpendicular to the plane, then the normal vector is parallel to the vector B. It means the direction ratios of this normal vector and this vector B are proportional, right? And since these two are parallel vectors, so we can also write this vector n is a scalar multiple of vector B, right?